My name is Corey Yang Smith, and today I'll be sharing IceLens, a hockey rink visualization full stack application I've built, available at github.com/CoreyYangSmith/web-bigdatacup. All the code, as well as documentation about the design, implementation, and deployment is available in the GitHub repository. We leverage the Big Data Cup 2021 hackathon dataset that is also open source. At the time of release, this application is live, deployed via Railway at web-bigdatacup-frontend-production.up.railway.app. On landing, the user will be presented with a table of the available games currently in the database. The user can click Analyze Game and will be brought to the actual visualizations. The purpose of this application is to provide coaches and analysts with the ability to dive deep into games and gain insights. It provides high-level visualizations that are useful for coaches, as well as more detailed analysis and data exports available for analysts who want to dig deeper. We have two main functions in this app: rink visualizations and tables. Starting with the rink, the user is able to filter by team, by player, or by event at the bottom, and all of the data that's pulled in the game timeline, as well as any visualizations displayed, will be reflected accordingly. We can see this reflected in our player stats here that are displaying the total shots, goals, shot accuracy, and penalties. In the center is the rink visualization that shows the events that occurred in the game, as well as draws arrows between passes, whether they're successful or not. This rink visualization is created using the NHL specifications for rinks and is a one-to-one replica that accurately reflects what happened in the game. At the bottom, we have a game timeline that can be scrubbed through, played, where the timer ticks up and shows all the events that happened, or the user can skip to the next available event. Again, this will be reflected based on the current selected player or team, as well as the filtered events. We also have the ability to see in further detail the event that happened, as well as information about the skaters on the ice, who was involved in the exact time step. Sometimes events will happen and be recorded at the same time step. On the left-hand side, we have a number of options available. Aside from some visual changes, as well as the ability to dynamically change team color, we have a handful of visualizations that may be useful for coaches or analysts alike. These include a heat map of the shot density, goal density, successful or unsuccessful passes, as well as penalty locations for that game, and an overall event heat map. Again, these will all change based on the people selected. Moving over to the table visualizations, we have the same player stats displayed at the top, as well as the data now displayed in tabular format. We include pagination and include the same ability to filter by team, player, or event type. If this isn't enough information, users are also able to export the data to JSON format for further analysis, or they can ask PuckQuery, our LLM-based chatbot that pulls actively from the dataset to give insights further than what might be displayed on the application. We'll ask which player has the most shots on goal. This sends to our backend, which is powered by GPT-4.1 Nano and performs a tool call to the pandas library. The LLM will write a query, pull from our actual data set, retrieve the data, and then promptly answer the user's question. If the user wants to go back and select another game, they can do so, and the right data will be displayed, as well as the settings saved from the last time. Thank you, and if you have any questions, please leave them in the comments below.